Hi everyone, welcome back to our YouTube channel. In this video, we'll be looking at the topic metal extraction. Now, by the end of this topic, you should be able to describe the differences between high-grade ores and low-grade ores. You should be able to explain why we need to get metals from low-grade ores and also evaluate the methods of extracting metals from ores. Most metals are extracted from ores found in the earth. Now, what is an ore? Well, an ore is a rock that contains enough of a metal or a metal compound to make extracting the metal worthwhile. Now, not all metals are found in ore. Pause the video and have a go at answering this question. Why are all metals not found in ores? Well, think about the reactivity series. Some metals are more reactive than others. Those found at the top are found combined with other elements to form compounds, so they're found in ores. However, those at the bottom, they're very unreactive, for example, gold and silver. As such, they're not combined with other elements. For example, gold is not combined with oxygen. It exists by itself in nature and not found in an ore. Now, metal ores can be placed into two categories: high-grade ores and low-grade ores. Now, high-grade ores, the advantage is that they contain lots of metal. However, the disadvantage is that they're running out. They're in high demand, so they're running out over time. Now, low-grade ores, disadvantage, they contain a very small amount of metal. They contain less than 1%. However, the good thing is that you have a lot of them. Now, why do we need to reduce the amount of high-grade ores that we're using? Today, we're using up a lot of high-grade ores. Pause the video and think about this. Well, high-grade ores, they're in high demand because they contain a lot of the metal in it. And as a result, because we're constantly mining these high-grade ores, they're running out gradually. The extraction method used depends on the metal's position in the reactivity series. To separate a metal from its compound will require chemical reactions. The metals found to the top of the reactivity series can be extracted using a process called electrolysis. This is where we use electricity to split up the compound. Now, in principle, any metal could be extracted from its compound using electrolysis. However, large amounts of electrical energy is needed to do this, so electrolysis would be very, very expensive. Now, the metals less reactive than carbon, instead of using electrolysis, we use a process called reduction, where carbon can be used to displace the metal from the metal compound. Reduction, it involves the loss of oxygen. So say, for example, we have copper oxide. The carbon can be used to displace the copper from oxygen, forming copper by itself and carbon dioxide. Now, those found below copper, silver, gold, platinum, they exist uncombined in nature. So all that needs to be done to these is to remove any other elements that might contaminate them. Okay, so we're going to focus on the extraction of copper. Now, copper can be extracted from high-grade ores and also low-grade ores. Now, the two main methods of extracting copper from high-grade ores include reduction with carbon, and also electrolysis. Now, from low-grade ores, the two biological processes that we'll be looking at is bioleaching and phytomining. Before we begin, I want you to create this flow diagram. You're going to create a flow diagram to show the different methods of extracting metals from ores using the keywords below. So pause the video, write these keywords down, draw this flow chart, and as we go through the different methods of extraction, you're going to be filling in the keywords in the appropriate position on the flow chart. Now, the first method that we'll be looking at is smelting or reduction. Now, our copper oxide ore, it's added to a furnace and then covered with carbon. Another name for carbon is coke. This is heated to a high temperature, and then a reaction will take place. Then we'll have our copper metal being extracted, and carbon dioxide is released in the process. Now, if copper oxide is heated with carbon to make copper and carbon dioxide, can you think of a word equation for this reaction? Pause the video and try creating the word equation for this reaction. And if you want to challenge yourself even further, try to come up with a balanced symbol equation for the reaction. Okay, now our reaction should be like this. It should read copper oxide plus carbon, arrow, copper plus carbon dioxide. Now looking at this reaction, can you explain why the copper has been reduced and the carbon has been oxidized? Pause the video, think about it. Well, the copper oxide, when it reacts with carbon, it loses oxygen, producing copper. And with reduction, this is the loss of oxygen. So because the copper lost the oxygen, it has been reduced. And in the same process, the carbon dioxide has been oxidized because the carbon gained oxygen in the process. As was said earlier, we can use electrolysis to extract all the metals from their ores. However, because it requires a lot of energy, only the very reactive metals, the ones above carbon in the reactivity series, we'll use this process for. However, when we want to purify copper, for example, to obtain pure copper from a solution of copper sulfate, we can use this method. Now, describe what you think electrolysis is. Look at the picture to the right and have a go at coming up with a definition or a description for electrolysis. Well, electrolysis, it's a process by which a solution is broken down into simple substances when an electric current is passed through it. To extract our copper from a solution of copper sulfate, we can pass an electric current through it, and that energy that it provides will allow our copper to be separated from the sulfate ions in the solution. So that's one method of extracting copper as well. Now, copper ores are becoming scarce, and scientists are looking into new ways of extracting copper. Now, these methods of extraction, these new methods, they include phytomining and bioleaching. These methods avoid the traditional mining methods of digging, moving, and disposing large amounts of rock, so they're less damaging to our environment. The phytomining method involves growing plants in soil that contains copper. The plants, they can't use or get rid of the copper, so it gradually builds up in the leaf. Afterwards, the plant, they're harvested, they're dried, and burned in a furnace. Now, the ash that's produced from burning contains soluble copper compounds, and these compounds, they can dissolve in water. In that form, we call them leachates or leachates, which contain copper, which can be extracted further by a process known as electrolysis, or we can use a process known as displacement using scrap iron. With bioleaching, bacteria is added to low-grade ore. The bioleaching bacteria feeds on the low-grade metal ores, and there's a combination of biological and chemical processes that takes place. At the end, a solution is formed, again known as leakate or leachate, and we can use scrap iron to displace our copper from the solution, or we can use electrolysis, as was mentioned before, to extract the copper from the leakate solution. Now, from bioleaching, we can obtain up to 20% of copper. Now, here's a quick summary of the extraction process. To extract copper from high-grade ores, we use smelting or reduction or electrolysis. And from low-grade ores, we use phytomining and bioleaching. And at the end, the copper solution that's formed, we can use scrap iron to displace the copper, or we can also use electrolysis to extract the copper.